現在整個產業都在做人形機器人。李飛飛的看法不太一樣，人的身體是為了在混亂的環境裡活下來演化出來的，不是為了把某一件事做到最好。他是 ImageNet 的創造者。今天 AI 看得懂圖片，起點就是他2009年做的那個資料集。他現在自己開的公司 World Labs 做的是空間智慧，白話講就是讓機器看懂三維空間。
I think your point here is that humanoids mimics human body, and evolution has optimized human body for unstructured environment. And so our fingers, our legs are not the best apparatus to do one thing. For example, if our only goal as a species is to climb trees, we will not have this body necessarily, right? So we'll have different kind of fingers. But what humans end up having are evolved into is this body shape that can be very general, but not necessarily best at everything. And that is for the survival of unstructured environment. But from a business point of view, from a pragmatic technology point of view, that this unstructured environment and a generalized body is actually the hardest problem to solve. It's not necessarily even the right way to solve the problem. We specialize, so we take more specialized body to solve a narrower problem.
那机器人要多久才追得上人？i16自己的主持人直接問了，回答的是坐在他旁邊那位윤助理，哥倫比亞大學助理教授，也是李飛飛在史丹佛帶過的博士後，他自己創的公司 Xenix 剛被 World Labs 併購，所以現在兩個人是同一家公司的。
Things up. And so this is just a prediction question, but do you believe we'll ever be able to build robots, at least in the foreseeable future, that have the power efficiency of a human being when it comes to menial tasks? So let's say just basically, minimum wage or something like that. Like, how far away are we from this? Is this like 5 years or this is like never?
I think it's going to take a very long time. So if you're really thinking about like robots in the real environments, in the end, it will always be a system. But we also have to be calibrated about our predictions. So we will see a lot of progress. But to achieve, for example, human level efficiency and capabilities, it will take longer.
Martin, the hardest thing in today's AI is to have the right measured optimism. Right?
Right. It's totally true. Yeah.
I mean, even LLMs does not have human brain efficiency. Human brain operates on 30 watts.
Yeah, that's true.
So we are far from that. So
他们两個湊在一起，不是為了做機器人，是為了解更前面的一件事。
My North Star is to make robots work.
Amazing, yeah.
In the real environment. I'm a very practical person. I want the robot to work. One interesting thing that's actually coming from my collaborations with Feifei during my postdoc, we are building this kind of benchmark. We actually send out surveys asking the general public what they want their robots to do for them.
Yeah.
Among the 1,000 tasks we collected, 1/3 of the tasks are about cleaning.
1000個任務，第一名是掃地。可是掃地機器人不是早就有了嗎？
People just don't like to do those dull and dirty tasks.
Right.
And those are the scenarios we really want to making sure we have robotic solutions to deal with.
那為什麼不直接讓機器人在真實世界裡練？
And if you really think about also the robotic evaluations, right now people are doing in the real environments, the iteration speeds is multiple orders of magnitude slower than iterations of those language models.
Yeah.
So not only is the robotic tasks very varied, very diverse.
Oh, yeah, because you actually have to do the thing.
You have to actually do the thing.
Right.
You actually
Like
break the glass.
atoms have to move through space.
Yes.
Exactly. Not only they are...
The laws of physics have to
and
be obeyed.
And have you watched those robotics videos? Every video has like 10x, 8x, because it moves so slowly.
Exactly. So not only it's slow, it's dangerous, it's costly, but at the same time, the speed is also multiple orders of magnitudes slower.
所以他们的答案是先蓋一個給機器人練習的世界。李飛飛說，這件事人腦本來就在做。
Think about human intelligence. We do a lot of simulation in our head. Why? There's a very important role simulation plays that real world data doesn't play, which is counterfactual reasoning, is that you play out events that hasn't happened or cannot happen, or you don't have enough data to make it happen in real world. And while you play it out, you learn how to act in it. Humans do this all the time. We probably don't. Here's a real life example. The industry of self-driving cars. Waymo has officially said they use billions of hours of simulation. And actually Waymo is more simulation heavy than just real world data heavy. So these are real examples. And as you know, Martin and Yunzhu too, cars are the simplest kind of robots.
Yeah, 2D. Yeah.
Yeah.
Of course, yeah.
So clearly simulation plays a huge role in robotic learning.
但那个世界要做到多帧。
Because what we are building is a consistent world. Consistent both over space, over time, over different viewpoints, and over different type of interactions. And Marble, the generated words from Marble, is also provide an infrastructure, a components of that entire words that we believe is necessary for the robot tuner. Imagine if a robot push an object forwards, the object just magically disappear, which has been a problem of many of the existing video prediction models. That's one provides good enough signal for the robot to know what is the right thing to do.
一边是人形机器人的期待被拉得很高，一边是连推一个东西它不要消失都还在解。李飞飞给的那句话是：今天的 AI 最难的是保持恰到好处的乐观。